In the name of Allah, hello to everyone. On this video I want to talk about the LinkedList data structure and its implementation is in Java programming language and in NetBeans IDE. The first, the difference between the LinkedList and the array is this, that the array's elements are continuous in the cells of the memory. So because of that they have the index, but the array LinkedList they don't and the LinkedList doesn't have these indexes because they are not continuous in the memory cells. So because of that they have pointers. I mean that they are pointing to each other, and by pointing to each other they create a link among themselves. So in here in NetBeans I have created a project, and the project and our main class is in LinkedList second, and I will write other codes in LinkedList. So the first we'll create a class in here, the name of node, that every node contains two things. The first and a value, that they have a value, the type of integer value, and the second they have a pointer. So every node contains two things. The first is integer value, and the second is the node next, that's a pointer. So in here we'll create a constructor that node constructor that it will take a value, and this dot value will be equal to value. The input value will become the value of the node there, and after that we'll create the head and the tail. The head and the tails are, every node has a head and a tail. The first node is called the head of the LinkedList, and the last node of the LinkedList will be called the tail of the LinkedList. So in here we'll create the node of head, and also the node of tail, and also we can have an integer of length that will be the length of our LinkedList. So after that we'll create a constructor of our LinkedList. So in here public linked list integer value that it will be as input, and in here I will create a new node. The new node it will have a value, and for the first time the tail and the head both of them would be equal to new node. So the head will become to the new node, and also the tail will become to the new node, and after that our length would become minus, or it will become equal to 1. So after that for printing we'll create a new function, for example public void print, and we'll create a node of temp that it would be equal to head and is out, and here would be the nodes of the linked list. So after that we'll use from while and until the temp would be not equal to null. So we will print the temp dot next dot value, concatenating with and space, and after that and the temp will points to the temp dot next. So in here, for example, in here, if our tail would be equal to 23 and we wanna add the 7, so our tail will points to the 7, and after that the 7 will become the next head in here for printing, and this pointing will save the new node to the temp. And for example, if I wanna run this program, so before that we should create in our main function in the linked list, for example, ll equal to new linked list, and for example 23 would be our first node in here, and after that ll dot print, we can print this value. So yes, we can see the 23 that it's the first node of our linked list. So if you want to add new nodes in our linked list, so we can use from the another function, for example public void append, that it will add a new node at the last of our linked list. So it will take a value of integer, and after that it will create a node, for example new node is equal to a new node of type a value, and it will take the value. So after this, if the length is equal to 0, so the tail and the head, both of them will become to the new node. Head is equal to the new node, and the tail would become the new node. So else the tail dot next will points to the new node. The tail dot next will become the new node, and also the tail itself will become the new node. So in here, for example, in the picture, we want to add the 7, the number 7, if our tail would be the 23. So after this, at the first, the tail the next will points to the 7, and after that the tail itself becomes 7. So for example, if you would use this, and at the end the length of the linked list will increase, and it will become plus plus. So we can use this function in here l dot append. For example, 12, 13, for example, 25, and we can run this program in here, and we can see these new nodes, and they are after 23, and they are 12, 13, and 25. So in here, if you wanna remove the last node, so this was the process of adding new node at the end of our linked list, and if you wanna remove this the last item or the last node of the linked list, so we can use for example from another function, for example public node for example remove, and so in here if the length is equal to 0, so we can return the null because there is not any node in here. So otherwise we create a node temp that it will become to hit, and after that we will create a node pray, for example, that it will also become to hit. So after that we use from the while loop until the temp dot next would be not equal to the null. So in this step we will pray would become equal to temp, and the temp will point to temp dot next in here. So after this loop we can say that till is equal to pray, and the till dot next will points to the null because the last item or the last node deleted, and we don't have any node in the last at the end of our linked list because we remove it and we deleted it. So in here the length will become minus and after deleting, so at the end we can return the temp. We can return the temp in here, so we can move it in here. So in here so we can test it, and if we want to remove the 25, so l dot remove, and the last item should be removed. Control S, and we run the program. So we see that our last item 25 has been deleted by using the remove function. So in here so this was the process of adding the new node at the end of our linked list, and also to remove this one. So and we can also use from our function that it will add the new node at the first of our linked list. So the concept and the code is very similar to the append function. We can copy it from here, Control S, Control C, and we can paste it in here, Control V. And the only difference between here is this, that the prepend function is in here. When adding the new node in here, the concept is like this, that the new node dot next will become equal to head. Will become equal to head, and the head will become to the next to the new node. So it's the only difference between the prepend and the append. And the prepend function will add a new element or a new node at the first of our linked list, and the append will add new node at the end of our linked list. Now, so for example, in here, if you see, for example, if our head would be 3 and we wanna add the 11, so at the first, the 11.next will points to 3 and will points to the head, and head become the 3, and head become to the head will become to 11. I mean that the 3, the new node assigning 11 will, the new node dot next will points to the 3, and the 3, that is the head, and the head will become the 11. And in this, by using this function, we can add a new node at the first of our linked list. And here we can use from the prepend function. So we can, for example, in here ll dot prepends prepend in here, for example, 100, and 100 should become the first element of our linked list, and we can see that the 100 becomes the first node or the first element of our linked list. So, and also we can remove the first element by using a very simple and function in here. For example, the public node remove first, and in here if the length would be equal to 0, so in here it will return the null value. Otherwise, the node temp would become equal to the head, and the head will become to the head dot next. The head will become to the head dot next. So, and after this step, the temp dot next will become to null. I mean that the temp dot next, temp dot next will become to null, and the first element will be removed, and the head will change to the second element. So in here the length will become minus, and after this our condition, if the length would become to 0, so in here the tail would become null. So it indicates that our linked list have only one node or one element, and after this we can return the temp node. here we can remove first, and in here we can use this you can use this function ll dot remove the first one, and after the running of this function, the 100 and the node that its value is 100 will be removed. So in here we see that the 100 has been deleted, and we don't have the 100 value. So these were the functions that we can use in this simple linked list, and we can have more functions, and you can work those functions. So another type of the linked list is the double linked list. In double linked list, the pointers are in two directions. For example, the 3 points to 23, and also the 23 points to 3. But in the simple linked list, the 3 only points to 23, but the 23 doesn't points to 3. But in a double linked list, this will happen, and we have two directions of pointers. So the only difference between these two types of linked list are only the adding of a new node and a new pointer. For example, in the append, we can have the tail.next is equal to new node. Tail.next is equal to new node, and we can have that the new node.prev is equal to tail. And in here, before tail, before head, tail, and also the next, we can also have the prev, the node prev. We can also have node prev, and it will points to the previous node. So in the append, for example, in the append, we can have also this type, that the tail.next is equal to new node, and the new node dot prev is equal to the tail, and it's the double linked list, and the only difference is in here. Or for example, in the remove, in the removing also this will happen, or in the tail is equal to next, the tail is equal to next, for example, or the new node dot next, and in here the only difference between the double linked list and the simple linked list in here is the two directions of the pointers. So in the double linked list, we can bring a very little change in our code to change the simple linked list to the double linked list. So for example, in the remove, if the length is equal to 0, so it will return the null. So otherwise, if we can remove this, and our condition is that if the length is equal to 1, so on that case the head and the tail are become null, both of them. The head and will become null, and also the tail will become null, and else both the tail would be equal to tail.next. Tail would be equal to tail dot prev. I mean that prev. So, and also the tail dot next would be equal to null. The tail dot next would be equal to null. Now, so in this case, the temp dot prev is also become to null. The temp dot prev is also become to null. Become to null. For in here, so in here we can the length will become minus. So in here, else if we see in the picture, we have for example, we want to remove the 7. The 7, the 23 dot next should become null, and also the 7 dot prev should become null. These are the simple type of the double linked list and the simple linked list differences only in here. And because we doesn't we doesn't created the temp the node of temp after this, so we create node temp that it would be the tail. So in here it will remove the last item or the node of our linked list. So the differences between the simply and double linked list are only the prev pointer, that it points to the previous node. Or we for example, we also can bring change in, for example, prepend, or for example the remove last item. For example, in the prepend, the new node dot next is equal to head, and the head dot prev means the head dot prev is also equal to the new node, and it's the only change, it's the only difference. For example, in the remove list is also like this: to remove the first, that it removes the first item of the linked list. And these are the simple changes. For example, in here we can bring a very simple change, that if the length is equal to 0, so it will return the null, and the node temp is equal to head, and if the length, and in here we will add a new condition that we can have this, that in here when the head is equal to head dot next, whenever the head is equal to dot next, we can have whenever the node is the node temp is equal to head. So in here we can have a condition that if the length is equal to 1, so if the length of is equal to 1, so both of them, the head and the tail become null. The head and the tail become null. So in here, else condition, that the head will become the head dot next. The head will become the head dot next, and vice versa. The head dot prev, the head dot prev would become equal to null. and after that temp.next, the temp.next will become to null. And by using this technique we will remove the first item. The length will become minus. So this technique will remove the first node or the first item of our linked list. So these are the very simple logics of the double linked list. And also we can have different kinds of the linked list, that is the circular linked list. If the head and the tail become connected, so the tail dot next would become the head, and the head dot prev would become the next the tail. This type of the linked list would become circular, and it will works like a loop. In here, for example, we can bring a change to the prepend. If we have in the prepend or other functions, so we can have the prepend functions, or in the print that in here. So in here we want to work the circular linked list in the prepend function. So if we have a node and we'll create a dot. So in here if the condition, if the head is equal to null, if the head is equal to null, so in here the head would become the new node. The head would become to the new node, and also the tail would become the new node. Tail would become the new node. So in here, and after that vice versa, means that the new node dot next, the new node dot next would become to null, and also the new node dot prev, would become also null, and it's the condition when the head is equal to null. So else in here the tail dot next will become to new node, and new node dot prev would become the tail. The new node dot prev would become the tail, and tail will become to new node. Tail would become to the new node. So this is the process of adding a new node at the first of our linked list. So after this, it's the process of creating a circular linked list. So the tail dot next will points at the head, and vice versa. The head dot prev will points to the tail, and in here the circular linked list will be implemented. The circular linked list. So it's the circular linked list, so we can have it in here. For example, in here we have the append to 12, 13, 25, or prepend the 100. So in here we can run this program first. Yes, and in here we can prepend or other values in here. For example, ll dot for example prepend, for example 100. Now for example control D 200, for example control D 300, and these are the values in here, and control S, and we can see that in here we have a loop, and it shows that this is the loop, and it shows that here we have a circular linked list because it's create a loop, and it's the result of a circular linked list, that 23, 100, 200, 300, and again 23, 100, 200, and 300. I means that in here it's creating a loop like this structure or this picture, and it becomes like a loop that its condition is always true. At the end it will continue until it will use until the using of all the memory. So our video is at the end, and thanks from all of you, and goodbye. Have a good day.